that's why I led this particular evolutionist to say magnetism is almost as much of a puzzle now as it was when William Gilbert wrote his classic text concerning magnetism, magnetic bodies, and the great magnet Earth in 1600. So 400 years later, we're still trying to figure it out. So here's what they aren't telling you about the Earth. It's uniquely designed for life. Its rotation period, axial tilt, orbit, atmosphere, and many other things. There's plenty of water here for the flood, even though evolution says it shouldn't have any at all. And the magnetic field can't be billions of years old. Now, we have a neighbor, our moon. The moon is also uniquely designed. It's close enough so that its gravity creates tides in our oceans. This actually prevents the oceans from being stagnant. The tides, as they come and go, help the ocean to circulate and prevent stagnant water and layering and all sorts of other things. I'm not an oceanographer, but this is what the experts say. Conversely, if the moon were significantly closer, the tides would be too much and harmful to us. Imagine having a tsunami on the coast twice a day. Wouldn't be a good place to live. So the moon's placement and its effect on us actually helps this be a nice place for us to inhabit. And the moon is, incidentally, at exactly the right distance to produce certain kinds of signs and seasons. I'm talking about solar eclipses. Now, the moon is much smaller than the sun. It's only 1/400th the size of our sun. However, by an amazing coincidence, the sun is 400 times further away from us than the moon is. As a result, the apparent size of the moon and the sun are exactly the same as viewed from the Earth, which is why, as the moon goes around the Earth, sometimes it winds up in between us and the sun, and we get solar eclipses, which I'm told, I've never seen a full one, but I'm told that a full one is an awe-inspiring sight. Now, there was an article written a while back trying to calculate the chances of this happening just by random coincidence, and, it's ridiculous. Nothing else in the solar system even comes close to the system we have with the Earth, the Moon, and the Sun, the way it's all positioned. The Moon is also uniquely studied. It's the only other object besides Earth that people have actually landed on and walked on. The famous photograph of Neil Armstrong. But we went there to do more than just plant a flag and say, wow, this is nice. We also wanted to study this thing, to explore as much of it as we could. First of all, you'll notice large dark areas on the moon here. Those are called maria. It is believed that these are the lunar equivalent of lava, where something hit the moon hard enough to actually crack the crust, and lava oozed out of it to fill in all these basins, and then after it cooled, it's a different color than the rest of the terrain. You can see the lunar terrain by itself is fairly featureless, but when you see the intersection between some of the maria and some of the highlands, you can see how this looks like these mountains were here earlier, and then it was all filled in by this material, which sort of flattened it all out and cooled. Now, the interesting thing with the moon is, I showed you a moment ago, let's see if I can go backwards in this thing. Hey, it works. I showed you a moment ago that this side of the moon has quite a few of these maria, and depending on where the sun was when you take the photograph, these maria are either accentuated or diminished, depending on how the light falls on them. But other photographs of the moon will actually show more of these than this, large areas covered in this material, indicating that this side of the moon was beaten up pretty bad at some time in the past. Well, you would think then that since this all happened over billions of years from all these planetesimals crashing into each other, that the opposite side of the moon should look the same way. But when we first started flying spacecraft around it, we were surprised to find that it isn't. There's craters on the opposite side of the moon, certainly, but there's no maria like this. So the moon appears to be asymmetrically beaten up. Something whacked this side hard a good couple of times and not the other side. Now, does this seem like the moon was going through this cloud of asteroids for billions of years, in which case, through random chance, you would expect they would be evenly distributed? It doesn't seem to work that way, though. One of the big questions that the Apollo missions were meant to answer is, where does this thing come from? Part of the astronauts' job while they were walking around was to take samples. This is Apollo 17 astronaut Harrison Schmitt, who was actually a trained geologist taking samples. And they brought back hundreds of pounds of moon rocks, which we put in the laboratory and analyzed them and did all sorts of fun stuff. the Apollo missions were supposed to answer this important question: which one of these three theories is correct? At the time the Apollo missions went up, there were three competing theories: the fission theory, the nebula theory, and the capture theory, each one of which claimed to explain where the moon came from, and Apollo was supposed to help decide which one was correct. Let's talk about each one of them. The fission theory says that the early Earth was spinning rapidly, and that as it was spinning, a chunk of material tore off of it and became the moon. And in some variations of this theory, the Pacific Ocean basin is actually the place where the moon came from. So that big spot on the Earth where there's no continents, that used to be stuff there that tore off and became the moon. The problem with this theory is that when the astronauts actually brought back some rocks, they found out that Earth rocks are different than moon rocks in some very important ways. The moon is deficient in iron, for example. And if the moon actually used to be part of the Earth, then the rocks should be the same, right? Also, there's a problem, too. The Earth would have to have been spinning very quickly for this to have taken place, somewhere around 2.5 hours for the Earth to zip around on its axis once, where what now takes 24 hours would need to have happened in just about 2.5. So the Earth would have had to have been spinning very, very fast. The problem is, where did all that excess rotational energy go? Because obviously today the Earth is spinning only 1/10 that fast. Somebody commented on this and said if the rotation of the Earth had been slowed by tidal friction from 4 hours to 24 hours, there would have been an energy dissipation of, big number. Such an energy release is sufficient to raise the temperature of the entire Earth by 1,000 degrees Celsius. In other words, to slow the Earth down, there's a lot of energy that's going into spinning it that you got to take away and has to go somewhere. If that was dissipated by friction among the tides in the Earth, as the theory says, this guy calculated that all that energy going into the Earth itself would have raised the temperature of the entire Earth to 1,000 degrees 1,000 degrees Celsius, which, among other things, would have boiled away all the oceans. So the fact that we still have oceans says this didn't happen. So the fission theory had some serious problems. The nebula theory, one of its competitors, says that the early Earth formed out of a swirling cloud of gas and dust, sort of a miniature version of that solar system thing I told you about, and that the moon just happened to form at the same time as the Earth did. The problems with this, number one, getting a cloud of gas and dust to collapse into two bodies like the Earth and the moon are today has some problems. Number two, why doesn't Venus have a moon? If this natural process happened all by itself, then how come our sister planet, quote unquote, that formed the same way we did, doesn't have a moon while we do? Substantial difference between the two planets there. Number three, the moon's core is proportionally smaller than the Earth's. They should have been the same if this gas-dust thing was where they both came from. And number four, as I already mentioned, Apollo missions show that lunar rocks are different than Earth rocks, which wouldn't be true if they came from the same cloud. So much for the nebula theory. So the capture theory, the third idea, must have been it then. This idea says that the moon was actually formed elsewhere in the solar system, thus conveniently explaining that inconvenient difference between moon rocks and Earth rocks, and was wandering through the solar system one day and happened to wander too close to the Earth and got pulled into an orbit where it set up nice housekeeping and has been ever since. Problem with that is, where did the excess energy go? It turns out that there's a fairly basic concept in physics that's being violated here. As the moon gets closer, it's being accelerated by the Earth's gravity. By the time it arrives, assuming it doesn't actually hit the Earth, let's say it's off to the side here, by the time it arrives, it will have enough energy to escape the Earth going in the opposite direction. It is impossible for one object to wander on by and get pulled into orbit like this. You have to slow this object down somehow. You have to break it somehow. Well, I won't go into detail on that. But basic problem with this idea is that the physics say it can't happen. And the second problem with this one is that although lunar rocks are different than Earth rocks in some respects, like I said, iron, they are the same as Earth rocks in other respects, in some of their isotopes. So the fact that they're different in some respects torpedoed the first two theories. The fact that they're the same in the other respects torpedoed this one. So at the time Apollo went up, they were hoping to reconcile these three, not reconcile, but find out which one of these three theories was correct. And it's interesting reading the arguments about those theories at the time. Each proponent of each theory didn't say, well, my theory is better because of X, Y, and Z. They all said, well, it can't be your theory because it has problems A, B, and C. So they were all pointing fingers at each other, showing why each other was wrong. So in a sense, they were all right because they were all wrong. Here's a quote from the Time. In spite of everything that we have learned during the last few years, we still cannot decide between these three theories. Notice this is 7 years